So it is recording now. So today we're going to resume a little bit from Monday's work, where we were using the dplyr package, but it's in the tidyverse, so I'll just be lazy and just load in tidyverse. We were using the NYC Flights 13 package, which has the flights data set. So I'm going to run this, and it should show just a little bit of the flights data set. It's a Tibble, big giant data set with lots of cases and lots of information about each case. All right, and we learned we learned a variety of functions from the dplyr package to manipulate data sets, which is a useful thing prior to doing an analysis. Maybe you want to chuck out some data, or maybe you want to do some quick looking at what the data is like. But it was a little laborious with the way we were doing it. I'm going to show you something today that is part of dplyr that I haven't shown you yet, and it will make your code easier to read as a human. So what do I mean by that? Usually when you're doing sort of data preparation before you do an actual model on the data, you do a lot of steps, and your code can start getting confusing as you do more and more things before you do the model. To illustrate this point, I'm going to, where it is. I would like you to consider the following pros. Okay, so human readable, people, this is one that actually has been in my head all morning now, because so humans are very good at reading and then hence remembering narratives. It'd be nice to be able to structure our code in a way that expresses a kind of story of what's happening. So here we have a central character, Little Bunny Fufu, who does a bunch of things. So each line actually refers to Little Bunny Fufu doing something. So we can understand that if we start with this Little Bunny Fufu, it's just the thing that's doing the actions on the subsequent lines is still this Little Bunny Fufu. Now, he may be modified somewhat as he goes through his actions. So after this line, he has a field mouse in his hand, and he's then able to do this other action, which is pop them on the head. So let's try to convert this into code somehow. So one first attempt might be something like this. So we first define an object called Fufu. It's a little bunny. And the way these rest of the lines, every line has a verb on it, has a preposition, and a noun. So we're going to say verb, and the preposition is the argument in the noun. So you can see that first we start out with Little Bunny is assigned to this object Fufu. So then we want to say, okay, Little Bunny Fufu hops through the forest. And we assign the result of that to this new thing, Fufu1. And then we want to say Little Bunny Fufu again still, after this operation has happened. Little Bunny Fufu is scooping. And what is he scooping up? Field mice. And finally, again, the Little Bunny Fufu that is after this operation, which gets assigned to Fufu2, is bopping said field mice on the head. Okay, so this is a little bit human readable. If I prepped you with this story, you might get a sense as to this story. It's a little less than ideal. There's a lot of repetition here. I have to add this object in every single time at the outset, and I'm assigning back the result of whatever operation it is to a new variable. So that means that I have to create these extra variables that, Afterwards, I'm never going to refer to foo-foo1 after I've created foo-foo2. It's after this line I'm never, well, sorry, after this line I'm never going to refer to foo-foo1 again. So it's a little bit unnecessary to have it like hanging around in our namespace. We also just had to have some cognitive effort to come up with a name that we'd then later use just here, but then never have to use again. So this is a little less than ideal. Up until recently, this was an option for how to express this story. There's another way to express this story whereby we don't bother saving the results of each of these operations. We can actually just nest them all together. So here's a different version of it. Again, we create the object foo-foo, and we run this function. And the function, you'll see this a lot in particularly other programming languages, but also possibly in some other people's R code. Hopefully it will start to disappear, because this is incredibly hard to read. Because you have to read from like the innermost tab out. So first you run this. You can actually the white spacing is even off a bit. You'd want to say foo-foo. And they don't use my. So you find the innermost indent, and you find the function that's there. Okay, so we're operating on foo-foo, hop through the forest. The result of that gets passed as the first argument to scoop up the field mice. The result of that gets passed to bop on the head. So we didn't need to create each of these intermediate values. We could do it all at once. But this is incredibly hard to follow, like if you're just going to glance at it. This is easier to follow because you're just one thing is happening per line, but you have to create these intermediary variables. So it'd be nice to have some sort of happy medium here. One approach is to do this, where it's kind of like what's going on over here. You're creating intermediary variables, but actually you're not. You're returning a result of each line to an object, but it's the same object as original. So you're overwriting what was in foo-foo with the result of each one. That's a little bit better. There's some arguments for never overwriting an object. It can make things harder to debug. And there's still a lot of repetition here. You have to type foo-foo a lot. So not great. So the innovation that's come out recently in R, and it's just been in the past like 5 years-ish, is this. So you create foo-foo, and there's a new set of characters as we look through this. And the new set of characters is this thing. Percent sign, a greater than symbol, and a percent sign. And this trio of characters is called a pipe. And what you can imagine, if these functions, hop, scoop, and bop, were created properly, R will interpret, say, this little bit. I'm going to hide this. As, okay, take the object foo-foo and pass it as the value for whatever first argument hop has. So it's the exact same thing as this. We do specify something for the second argument, but it's a little less typing, and it's a little more readable. You're saying foo-foo is the object that's going to do a bunch of things. And the first thing it does is it hops, and where is it hopping? It's through the forest. And ditto, we can actually pipe the result of this to the next action that foo-foo is going to do. So this has modified foo-foo a bit, so now it's hopping through the forest, and it can encounter this other verb. So this process, this sort of new thing, a pipe, actually makes code a lot more readable. It's less typing, and it starts to make it like a story so that you can follow what's happening as you go through.
This may be a bit of an aside, but if you created fufu as a vector, say with 2 entries. Could you pass that as like both, like the first two arguments into hop, scoop, and bop?
Well, the way we're going to be using it in the context of data wrangling is that usually when you're piping, you're starting with a data frame or a tibble, and that has columns that are referred to in this. So what you're describing isn't a typical usage.
Okay.
There are more advanced usage of piping that I've personally not encountered or not had to use myself. That might satisfy, but
theoretically you could, would be reasonable.
maybe.
Whatever
Yeah,
reason why.
I don't know. Is actually the answer. Yeah. So let's take an example. We had the other day. Pull up the following. In demonstrating the use of mutate, I needed to take the flights. I used select on the flights. So it was, what did we say? It was .data is flights. And I'll put a dplyr here just in case, because I think, oh no, just in case I'll put dplyr. So we created this new object called flights SML, small, that just had a few columns. Let's just take a look at it. So it's a subset of the columns from flights, and then we wanted to mutate it to add a couple columns. So the next command we had run was a mutate on flight small, and we added a bunch of columns. And we didn't assign it back into anything, we just had it print the screen so that we could see that now there's a gain column, a speed column, and a gain divided by speed column. Because we have multiple operations here being kind of done being done on a data object, I'll add in first.data equals that, and I'll say dplyr, just to be explicit. All right, so this is the old way of doing things. The new way, which I'll actually just go ahead and overwrite what I have here, is to, maybe I won't. Well, yes, okay. Is to, instead of passing flights as the argument, as the first argument here, we can actually just take off that whole line, that whole first argument line. So now select starts with that. We'll take off the assignment. We'll say flights pipes to dplyr. Dplyr select. I usually tab that in so I can kind of see the start of a chain. And the result of that will get piped to a call to mutate. And now mutate doesn't have to have a data object passed in because it's going to receive the data object, the data frame that select produces. So you can see what's going on here. It's a little bit easier to read this code. We're taking the flights object, we're selecting on it, and then we're mutating. Have another example here. The other day we had an example where we just wanted to do a group by and then a summarize. So we wanted to say, with this flights data, they have data for flights for each year, month, and day, and if we wanted to get, say, the mean departure delay for each, say, month. Before we would first of all create a new object that filtered only to those flights that weren't canceled, so we had to create a new object for that, and then create another object that was the result of calling group by, and then a final object that was and then finally run summarize on that grouped object. Now we can just do it all in one pipe. We say flights And first we're going to filter. We want to get rid of all those rows for which depth delay is NA.
I have a quick-ish question.
Okay.
I thought I was making notes and stuff while you did this. If you were to call, say, like from line 5, flights, and then pivot into all this, at the end of this, if you were to view flights, would you now have the output from this, or
No.
would it not overwrite flights initially?
This doesn't overwrite flights. I haven't assigned it into anything. I could put at the very beginning flights 2 equals this whole chain.
Gotcha.
An alternative that I used to never use the right-hand assignment arrow, but I've started to. So if I actually did want to do a chain and save the result, I would put it here because it kind of, again, has a linear flow to it.
Right. That's what I wanted to clarify.
Yep.
Okay,
But
make a follow-up though. So as is, you just run that and you get like.
and it just prints the screen,
Oh, yeah,
and then it disappears. It's erased from memory thereafter. It's just printed to screen and it's gone. So if you wanted to actually do some further computations on that, you'd have to either add those computations to this chain or store it away and then have that second object to compute on. So I was demonstrating that another example of using pipes. We want to first toss all those rows for which the entry in the depth delay column is an NA. And then we want to group by month. And summarize. So we want to get the mean departure delay. Call it mean DD. Mean depth delay. So we can run this. Oh, flights. I can run this, and I didn't need to create any sort of intermediary objects to store the result of the filter or to store the result of the group by. I just run it all in one chain, and it gives me the result.
To be clear, when somebody's reading this, would you add kind of a comment saying what this is doing? Because it's not really clear from like the header flights that you're like getting the mean.
Yeah. So you typically put a comment at the top what the chain is going to do. You could also put a comment like right before each step of the chain. You're allowed to add comments in line here. So first filter out NAs, add grouping by month, compute summary, so that will still run, and you have a nice little description of what's happening on each step. So yeah, this is the new way of doing things, is using pipes, and it tends to, I'd heard about it like about a year or so ago, but I just only in the summer started converting all my code, and I'm a definite convert in terms of this is, having written a lot of code that doesn't do this, this is the better way to do things. It makes for much easier to read and frankly easier to write code. So, yeah.
If you didn't put summarize and just put mean, would it just spit out the mean? Or why is that necessary?
Okay, so I put summarize, because summarize is a function that will take a data set and compute some sort of summary statistic on the columns. You have to tell it what column you want, and ideally you do a grouping ahead of time so that it does it by chunks. You could just get the mean of all the departure delays, but that's not as useful as being able to group it. But so you have to tell it, like you have to name it the new column it's going to create, and you have to tell it what what computation you want done on what column.
Oh, so it's actually creating a new column.
Yeah.
Okay, thanks.
Yeah, exactly. So yeah. Yep. I think I had some. Here's another example, kind of using the like you can imagine longer chains where maybe I'm going to steal this part. In addition to filtering, then you do a mutate to add a column, add these columns, and maybe it's one of those columns that you want to get the summary on. I'll just call it value. Oh, what went awry there?
Are there NAs in gain div speed?
Mm-hmm. A good test of that hypothesis, na.rm equals true. Yep, there were. So, oh, I bet you, how could there be not a, I don't know why that would happen.
Well, you haven't checked if there's any NAs in arrival delay or speed, right?
Okay.
Because if they got canceled, they would have no air speed and no.
Okay, let's take this opportunity to actually investigate this. So, this is actually another reason why I like pipes, is because you can actually break the pipe temporarily and to figure out what's gone awry in your pipe. So I'm going to immediately filter and then just do a summary. And I'll ask any is a, we'll take a logical string. So I'm going to say any is.na r delay. Yes, there are some. So even though we filtered out the departure delays that are NA, that's a little weird, because you'd think that if it was an NA in the departure delay, or sorry, if it were an NA in the arrival delay, it should be an NA in the departure delay. So seemingly some flights did take off, but then never arrived.
Well, we have bad weather and arrive later, right?
Well, you think that though that would just
would
be
still be a delay.
a delay. So
Is the value for no delay 0, or is it maybe NA for there wasn't a delay?
Maybe if they didn't end
Can
up
we ask
like
if
where
there
they were
is 0
scheduled.
in arrival delay?
can you ask if there is a 0?
Yes.
Yes, you can. So let's take out the NAs.
Or
NA.
is false or whatever, I guess. I don't know. Consider it.
NA. And I'll add another thing. 0. Oh, can't put 0 at the beginning. Any arrival delays equal to 0. All right, so we're trying to toss the NAs for arrival delays. So this one should come out as false. But is there any that are 0? Those might be, no, those might be valid flights. They just arrived right on time. So that doesn't really tell us much.
I wasn't sure if it was, instead of using 0, like you were using NA.
Yeah, exactly. But, I mean, that certainly gets rid of those arrival delays, so we can actually just take this out now, put our pipe back together, and run it again. And now, oh, actually, I'm going to go and, oh yeah, I took off the NARM there, so that was the cause of that NA.rm, was because there were seemingly some flights with an NA in arrival delay, but not an NA in the departure delay. So when we only took out the NAs for departure delay, it still left in a bunch of ones with arrival delay, and that made the gain not compute properly, which then made this come out as having NAs. So, yeah, pipes are fun. Highly suggest that as you go through and try to modify things, just use pipes. We're gonna take a break from data wrangling. So you have all the tools to do all sorts of summaries. I'm going to suggest that you start trying to get your hands on some data sets so that you can start applying the tools I've given you for reading in data and then the tools for wrangling it to get into a state where you might want to start looking at it. I'm going to show you the tools now for how to actually visualize things about your data. Visualizing being a useful way of just getting a sense as to what's going on in the data. And eventually we'll get to modeling, and that's going to be next week. So, visualization package that's core is the ggplot2 package. That's already loaded in by tidyverse, so you don't need to load it in at all. But you're going to see me typing ggplot2 : a lot. GG stands for the grammar of graphics. And the real innovation why ggplot2 has become really popular. So ggplot2 became very popular before even the tidyverse was around. So that really made the name for the person that created the whole tidyverse. It has become popular because it is a very it has a very straightforward yet flexible way of expressing how to create a graphic. It's the GG part, grammar of graphics, actually comes from another statistician who wrote a book. I think it was called The Grammar of Graphics. Is it Cleveland Wilkinson, I think? So the ggplot2 package simply implements that grammar. And the idea of a grammar is that there's some sort of set of rules for translating what we have as data, numbers and different columns and things, to something that's visual. And the general idea is that you have aesthetic attributes in a graphic, and you are trying to map features of the data to those aesthetic attributes of the graphic. So to illustrate this, we're going to use the MPG dataset. Since we loaded up tidyverse, the MPG dataset should be just available. So if I take a look at it, tibble with 234 rows and 11 columns. This is a dataset describing a bunch of cars and like their what kind of car they are and what like performance they have. There is a chapter in the R for Data Science that deals with visualization, and they actually do visualization before they do anything else. So you can take a look at that now if you want. They deal with the MPG package. I'm going to have this content loosely based on how they go through things. I will be showing you in a slightly different way, though. So I want to create a visual on this data set. Let me actually do a view on it. View, MPG, and I'll take a look. So we've got a table here. There's a bunch of columns. Manufacturer, model, engine displacement, year, cylinders, the type of transmission, drive, four-wheel or forward. Forward and, rear. Yeah, that's right. City mileage, highway mileage. I have no idea what FT?
L?
Is that FL?
FL.
Yeah.
Anybody know what that is? As a variable? Class?
Something that depends on whether it's right or left, maybe?
Let me actually, I think
Oh,
we can
no,
do
it's
question
R.
mark MPG.
Field type.
Okay, so question mark FP gives me the description, fuel type, good call. So let me see.
No, it's valid. Fuel.
Yeah, so we've got P, R, and E.
Propane, probably.
There is a D.
Or
No,
petrol,
petrol.
Petrol.
electric, diesel.
Diesel.
I don't know what R would be.
R.
Regular and premium.
Ah,
Yay.
good call.
And I don't know what you use.
Yeah, electric, I bet.
Oh.
Diesel.
No,
But it's
you would say
2008.
electric.
No.
Yeah.
No idea. We're not going to deal with that column anyway.
Oh, it could be E87, like for E85 or whatever it is.
Yeah.
high ethanol content.
Oh.
What's C?
Gotcha.
Crap.
Yeah. All right. Okay, so I've got this data set. I'm going to do a quick plot, just a scatter plot of, let's see, what did I have here in my already created code? Engine displacement against highway mileage. So how big the engine is against how efficient it is on the highway. So the creation of all ggplots is the first starts out with the creation of a canvas. So I'm going to create an object called canvas. Again, that's an arbitrary name. I use the term canvas because really it represents a blank thing that we're going to draw on. So to initialize that canvas as a blank thing that can be drawn on, we refer to the ggplot2 package and we use the ggplot function. Whoops, ggplot. So this creates a blank canvas that we can then draw on. We're then going to create some objects to add to the canvas. So I'm going to create, I call them layers, each object, because you can layer the objects one on top of one another. So the points layer is going to be ggplot2 has a layer function. So I'm going to add a layer to this object. I have to tell it, I'm obviously going to be giving it data and mapping some columns from that data onto aesthetic attributes. So I need to tell it what data to use. So it's the MPG data set. I need to tell it that the geometric object that I want to actually draw is a point. I think, yeah, point. And I need to tell it what, so a point has a variety of aesthetic attributes. It has a location in the x, it has a location in the y, it has a size. Any of those attributes, there are default values for each of those attributes, but any of those attributes that I want to be variable or mapped to a column in the data set, I need to tell it explicitly what that mapping is. So there's an argument to layer called mapping. And what mapping wants is a list of, well, aesthetic attributes mapped to which column in the data set. So the thing that you want to pass to mapping is a list created by AES. Remember I said that you could use C to create a list of numbers. Well, if you want to create a list of these aesthetic mappings, it's the AES function that you want to use. So I'm going to actually add some white space here. So I want, by putting x equals dispo, dispo being one of the columns, the engine displacement in that MPG data set, I'm telling it that when it's trying to find for each point its x location, look in the dispo column. So it's mapping the dispo column to the aesthetic attribute of the x location.
Question. So you had to specify the layer was from the ggplot2.
Oh, yeah, if I were being consistent with my suggestions that you guys do this, I'd do that. You can kind of see why people don't follow that suggestion because
it's not necessary.
It's no. Yeah, in the yeah, exactly. It actually
Now,
Question?
sort of tied into that, I apologize if this is something that's covered before. If you're running, for example, the points layer, ggplot2, you call a function layer within ggplots2. As you go along, if you were to fail to put ggplots2 : AES, would, assuming that there was other libraries that included AES, would the function be smart enough to figure out, would R be smart enough to figure out that because you're in a function calling?
No.
So
No.
you can call different functions from different libraries within.
Yeah.
And
So that's
if you
why
don't
I suggest you.
specify-
Oh, yes,
Okay.
yes. This is why I always suggest you put it there, even though it's more typing.
So it would be an error in that case?
It depends on what the original AES function does, or what this new AES function does that you're imagining gets created by some other package. So yeah, always best to put that little bit there. So with a point, you definitely have to give it the X and Y locations, or the mappings for the X and Y locations. So what did I say? The highway was the one that I wanted. But it has defaults for like the size that it's going to print and the color and other aesthetic attributes that we'll look at in a bit. You definitely have to give it the X and Y though. So with just these two things, a canvas and a points layer, I can combine them. So I'll create a new object, combined equals canvas plus points layer. I'll actually start running these. So that creates the canvas, that creates the, this is new. They used to let me, so I've told you that I want a geometric object and that we're going to tell it the mapping of the aesthetic attributes. One other thing that layer wants is whether we're going to do any sort of summary statistic on the data before we want to plot it. We don't. So stat equals identity will make it so that it doesn't try to compute any means or anything like that. It's just going to plot the data as is. Oh, you... Okay, this is coming from the fact that I'm using ggplot a little bit differently than typical to illustrate some principles, but so this is why I keep forgetting. So it also wants a position. Well, actually, this is a good one too. So position equals identity, we want that. We don't want it to, so I'll show you in a moment a scenario where you might not want position equals identity. So position equals identity will say, really, put the position that I'm telling you by the X and Y. There's other things you can do with position that seem like it wouldn't be useful, but they are. So, but for now, position equals identity. Okay, so now I can create this and finally combine them, and nothing's happened. It's because you need to actually print the resulting object, combined, and your plot window should auto-expand and show you some neat, well, it shows you on this axis is the dispo, and on this axis is the HUA. If we want to add in actual nice labels, we'll create another layer, labs layer, and there's a ggplot2 : labs. So if we want to say on the x-axis, put the label engine displacement, and on the y-axis, put the label highway mileage. I'm going to actually, instead of adding, so I could do that labs layer. I'm going to actually, you're allowed to put white space there as long as you keep the plus at the end of the line. If you don't do that, the R will reach the end of this line and think it's done. So you can't do the trick that I'd suggested for functions, whereby you put the thing that separates entries at the beginning of the line to help you remember if you've forgotten them. You can't do that when you're simply adding things together. But we'll just...
So the white space matters?
No, it doesn't matter. It matters if, like, so when R hits the end of a line, it checks, hey, am I expecting anything else? If there isn't, so if there's a plus there and it hits the end of this line, it knows, oh, they put a plus there, so they must intend for something more to happen. So it ignores the white space then.
Right.
But if it isn't, if it's unaware that you're going to be doing more things, it just it will just stop. And
that's weird because I thought returns don't affect the flow of the process, right? You just select all the line.
yeah, well, it kind of does in the sense that it needs to know when a function, unless it's actively inside a parentheses, it just assumes it's done, and you want to do the computation. Otherwise, if you did 1 plus, and if you started typing 1 plus 1 and hit enter, how would it know whether you want to continue or not, or get a result? So, yeah, only inside parentheses or quotes, or if there's a plus sign, does it ignore return? Question?
Is there a way to set this up so that you don't have to individually create each of these components and then wait?
Yeah.
Okay, I figured,
right.
but
Okay.
you didn't have to explain it. I
Yeah,
just wanted to
we'll
be
get there.
sure.
We'll get there.
Yeah.
Okay, so, I didn't actually run this. So I'm going to create the labs layer, I'm going to combine them, and I'm going to print. And now we've got nice little labels. And there's a whole bunch of just background aesthetic things that you can do, like the color of these labels and the color of the background grid and everything like that. If you do !, theme, that will give you a help. We're not going to go into that because there's just so much you can tweak. I think there's a lot of good things online about the different themes. Let me actually go. The ggplot2 website. Docs.ggplot2.com has a bunch of help topics for each thing. We're down here should be themes eventually.
Oh, that order.
There we go, themes. So the main help one is theme, and it'll give you a preview of a variety of different themes that are available eventually. Here we go. So setting the border to pink, getting rid of the background. So there is a whole theme called Theme Black and White that will set a whole bunch of options. So theming is a really good way of theming is the way you tweak some of the peripheral aesthetic attributes. Adding a title is done by, labs. You can add a title by labs. I'm not going to get too much into doing theming because there's some good documentation on it, and the default visuals that come out of ggplot have been designed to be fairly publication ready. You can't say that about the base R plotting. They don't look very nice. Quick question?
Yeah. Are you only able to do 2-dimensional plots on this, or can you do 3-dimensional?
ggplot is purely 2-dimensional.
Okay.
Their ggviz, I think, has some 3-dimensional stuff because it's kind of like a web-based version of ggplot, but I haven't explored it myself. So yeah, only 2-dimensional. Okay.
Can I ask you about an error I'm getting?
Sure.
It says error is.logical, and then in parentheses na.rm is not true.
So you're trying to create this plot?
Yeah.
I might have to double see that after class, because I'm not sure.
Same code as yours.
I must not have something loaded or something.
Did you
Well,
load in the ggplot thing?
If you have tidyverse, I mean, it would give you an error about ggplot not found if that were the case. Okay, so there is a lot of Oh, I promised you that I would show you that maybe you would want a different position than identity, even though we're trying to map positions to actual data. So one of the options for position here is called jitter. So I'm going to put that in and rerun everything and show it. You can actually see that individual data points have been pushed around just a little bit. So it's taken what's in our data for the location on the x-axis and y-axis for each point, but then it's added a little bit of noise. That can help you see when points have been overplotted. So in this case, engine displacement appears to be, so if I, oh, and just for the showing you the UI here, this plots viewer has a back arrow, so you can go back and look at previous plots that you had. So you can kind of see that there's some clear like columns of data. So there's like fixed values for engine displacement. There's a little bit of rowness to the data as well. So whenever you have that scenario with data, it could be that there's multiple data points right here or right there, etc. If you're plotting them with full opacity and at their true points, then you won't be able to tell when there's multiple data points overlaying on one another. Jittering is one way to make it so that they get pushed around a little bit so you can kind of see when there's multiple points. That's best combined with setting another aesthetic attribute, but making it so, and that's the transparency. In computer graphics world, transparency has the name, the term for transparency is called alpha. So so what I'm doing here is I'm saying alpha is not something that's going to vary according to the data. It's just going to be constant across all the points that are created by this. And alpha takes values from 0 to 1, so 0.5 means it's half transparent. So I'll run this. What is the, shoot. Geom, stat, mapping, position, params. There we go. Okay, so params equals. So any attributes, aesthetic attributes that you want to map to data need to be supplied as an AES list to the mapping argument. Any aesthetic attributes that you want to just be constant across all the geometric objects that you're plotting, you just give it a regular old list. I haven't told you guys about lists, but I told you that C has to be the same thing, same type of thing for every entry. A list doesn't. It's just a collection of anything. But here what we're saying is alpha equals 0.5.
Can you convert like from a list to a C and vice versa?
Yes, unlist is the way you do that, but then you get errors when they're not constant. A list is also a way to have a named set of items. So, quick question, yeah?
Yeah, just a question about like word strings. So with the layers, you have an X and Y engine displacement and highway mileage in quotes. It came up, as a word string there.
Yep.
But for stat and position, you're also using quotes, but it's recognizing identity and jitter as like internally and doing.
Yeah, these are like keywords that it knows about.
So
yeah.
like just knows some keywords.
Yep,
and you
exactly.
know the package.
Yeah, you end up memorizing what the options
so
are.
do you need those in quotes then if it's like recognizing those
Yes, because they're not objects that are like defined that it knows about.
Okay.
All right, so I'm going to run this and just show you what I mean by this alpha bit. Okay, so now with the combination of jitter and alpha, you can see sort of areas where there's particular overplotting. So that's both demonstrates why you would want anything other than position identity, but also how to just set a single attribute to be constant across all the points. There's all sorts of other attributes. So if I wanted color equals red, can make all the color points red. There's a bunch of shapes. Let's see, what is shape equals 2? There's a list of shapes. I can't remember what the different shapes are. So number 2 is a triangle. Let's see, number 1 is an unfilled circle. So you can do this to just figure out what all the shapes are. Number 4 is an X. So yeah, you can tweak what the constant color is, or yeah, the constant color, the constant shape, constant alpha. You can also add in if there's another variable that you want to. So we've said, okay, vary the X location of the points according to what's in the dispo column, vary the Y location of the points according to what's in the highway column. If I wanted to say differentially color them, I'd take off the constant color here. It doesn't matter if you use OUR or OR, it figures it out. So I need a column in the MPG dataset to map to color. Class, it's categorical, so it might be useful to map to color. So I'll run this. And now we should have a bunch of different colors, but we have a nice little legend here indicating what color corresponds to what class. There's so many classes here that it's actually not super useful. It's hard to see. I'm going to take... Sorry?
Nothing.
Okay. I'm going to take off the shape because you might be able to see it better.
So you can kind of do three-dimensional if you color according to shape.
Yes, you can
shape according to color.
Yeah, exactly. Like you can do n-dimensional where n is the number of categories. So if I wanted, if you mean by dimensional, how many
Like how many
columns in the
variables?
data set
Yeah.
you're mapping to aesthetic attributes, yeah. So that's color equals class. We can do, DRV has 3 levels, I think. So I'll say shape equals DRV.
Shape of the class.
And we'll get 2, well, I'll have to make it bigger, I guess. We'll get 2 legends, one showing you for each of the shapes what they map to, and the other showing for each of the colors what they map to. So each point is going to be a shape and a color. So
If you wanted to like fine tune, say the colors, which one's which, would you go to like the ggplot docs and like?
yeah, so there's a way to fine tune what colors are what. The colors actually, they've put a lot of thought into what colors come out, such that they try to make them, for example, luminance constant, but they view the hue, which is known to be psychologically better. Like it doesn't, if you were naive about it and you just like chose on a red, green, blue color wheel, those are going to vary in terms of both hue and luminance, and so some points will pop out more than others. They've done some work to make sure that they're choosing colors in ways that allow distinction of colors, but not emphasis of some versus others, or differential emphasis.
I mean, like new size minivan and pickup are all kind of on the same spectrum where it gets
Ah, okay. So
brown one or something stand out.
yeah, yes. So there's certainly ways to tweak what they actually choose there. I'll get into that maybe next time because I didn't have that on tap for today. The defaults are usually pretty good anyway, so I don't find myself needing to tweak them that much.
Presumably you can specify color by like more than just the name. Can you
Yeah,
use-
yep. You can use the full hex code for it, or I think it even understands things like light blue and things like that. But yes, you can also just give it like either the RGB or the hex code or all sorts of things.
I just found about this website literally today, where you can get the hex code, and you can also specify things like colorblind safe, printer friendly, photocopy safe, and so on.
Yeah.
Automatically format
Yeah,
it.
and indeed there's packages or there's themes that will automatically apply some of those principles to make it so that it uses colors that are okay for people with the various types of color blindness. So yeah,
Can you tell us what the website is?
Color Brewer 2.
Color Brewer. Yeah,
And it's a package.
there's a brewer package for our. Oh no, my battery. How am I doing? Ooh.
Do you want me to grab the charger?
9%. Yes.
That's the
Would you
smaller
mind?
one, right? I'm pretty
Yeah.
sure it's that
Yeah.
one.
Yeah.
Okay.
So-
So,
Okay.
perfect for
So let's combine some of our skills. So we've seen how to plot this. But as you can see, there's per engine displacement, there's a bunch of entries. That engine displacement seems to be somewhat grouped. So let's actually compute a mean engine displacement. Let me show you what I mean. I'm gonna put jitter back to identity, or position back to identity. Run all this. So ignoring the coloring and shaping, there's like a bunch of cars that have the same engine displacement. So what if I wanted to just get the mean engine displacement for each set of, for each engine displacement value, get the mean for that.
For the highway mileage.
Yeah, the mean highway mileage for. Okay, so at this stage, you guys should know how to do that. That's going to be using your data wrangling tools. dplyr.
So you're gonna summarize?
Okay, so at one point, so we'll start with the MPG data set, and we're going to start a pipe. So you're saying somewhere in that pipe is dplyr summarize. What would we want inside the summary? So remember, summarize, each row in the summarize call here, each argument is going to create a new column. So you have to tell it what the name of this new column is going to be.
Mean mileage.
I'll just call it mean highway. And we have to tell it what we actually want to compute as a statistic on what column. So we want to use the mean.
But we need to group first.
On highway. So why do we need to group? What is this going to just do?
It'll just give us the entire name of the entire highway column.
Aha, yeah.
So let's do this.
Yeah, I just got an error because I forgot one of the colons. So it's going to give us, if we just run it like that, it's just going to give us the mean highway mileage for all of the data set. So we want to do what?
Group by engine displacement.
Group by, and, or what is it called? Dispo.
Is it not the right one?
Work.
Yes.
Okay. Group by dispo.
You know, dipple.
Yep. Dispo, right? Dispo. Okay. So now let's run this. I should be able to see some of it. Okay, so there we go. So I'm going to store this in something mpg2. So triple checking that mpg2 contains just those two columns, dispo and mean highway. Now I can go up. I'm going to copy all of this. Put it down here. I have to go through and I have to tell it, okay, on this points layer, I want to refer to mpg2. And we no longer have a column called highway. We have something called mean highway. We don't have any class here anymore, so I'm getting rid of that, and drv is out of there. All right, so I'll create canvas, create points layer, lab layer, combine, and print. Aha. So there's the means. for each of those things. Whenever you have like a continuous variable like this on the x-axis with a lot of values, it can be helpful to connect the points. So we can add.
Sorry, just as I guess kind of an aside, is there any way to affect the alpha of this based on the number of observations for any given thing? The only reason I ask is because you look at the 7-liter vehicle, which has a highway mileage of about 25, and then you've got like 2.8-liter vehicles with a highway like. But I'm wondering, like, there's probably not that many 7-liter vehicles. I'm wondering if it's possible to make. You know what I mean?
So okay.
The more values, the more observations you have on a given thing, the darker the spot is going to be.
Okay, so we would want that's a good idea. So we'd want to, in addition to asking what is a mean highway mileage, we could also ask how many entries are there in this group. So this actually is one, so we'll add a new column, maybe call it num. And I haven't shown you this, but this is a very useful function that you can add in summary. It's n. It's just going to count the number of entries in the group. This will, for the group, it will get the mean highway. This will, for the group, just count the number of rows in that chunk of the data set as defined by the group. So you don't have to give it any arguments or anything like that. It just will create it. So if we run that and take a look at mpg2, it now has 3 columns, a num column. Which means if we wanted the alpha to not be constant, but to vary according to that num column, we can do that now. Okay, so those points with fewer observations are now lighter, more transparent. We could have equivalently said color instead of transparency. So if I do color, something slightly different than before has happened. Before, when we had color, we had a categorical variable. It was class. And so it chose distinct hues for each entry for each class. Here, we have a continuous variable, num. It's the account of the number of entries in the data set that are associated with that point. And so it's actually recognized that it's continuous, and it's created a continuous color change such that it's actually gone from a dark blue to a light blue. We can change that, again, if you wanted it to be like a nice heat map, like in fMRI, so that it's like red at the bottom, white in the middle, and yellow at, wait, what is...
Yellow-green?
Yeah, you can change this scale, this continuous scale, in the same way that I mentioned you can change what specific color choices are made for the categorical scale. We'll deal with that next class. So, yeah, that's creating yet another variable. But what if I want to just connect the dots? Well, I've got dots. That's one geometric object. Now I want lines. So that's a whole other geometric object. So what I'll do is I'll copy this points layers bit and paste. And instead of points layer, I'll call it lines layer. And instead of geom point, I'll call geom line. But otherwise, everything should be the same. I happen to know that color is going to break it because the points are going, the lines are connecting the points. So a given line, it's going to be uncertain as to whether it should have the color of the point at the beginning or the color of the point at the end. So I'm going to take that off for now. So it's just going to be black lines. So having created this lines layer, I need to add it to the list of things being added in here. Lines layer. And we can plot it. Now, I actually probably personally wouldn't have bothered adding lines to this plot. It's kind of prettier without the lines. The reason why I added it was because I wanted to point out something, which is we've got a lot of repeated stuff across here. The way I've been showing you so far has intended to convey that you can create a plot by adding on different layers. Each layer has its own geometric object that in turn refers to some data and refers to some list of mappings between this that attributes and the data that you're referring to. We can simplify a lot of this, or at least reduce a bunch of our typing. One thing we can do is, instead of in each layer telling it what data to use, both layers, at least both layers that have a geometric object, refer to the same geometric object. So any thing that we have inside the call to layer that's common across all the layers that we use can actually be put in this original call to canvas, or to ggplot. So here I'll say data equals mpg2. And now I can actually get rid of this first argument. I need to remember to take off the first comma. So, and just to demonstrate that this works, I'll now I'll run this little bit to redefine canvas, run this bit to redefine points layer, add them all up, and it still works. So we've reduced our amount of typing by 1 line so far. Additionally, any mappings that are common across the layers can also be put in the call to ggplot. So what's common? X equals dispel, Y equals mean are in both of these things. So I'm going to copy the lines layer 1 and just put it right there. So now ggplot has a data argument passed to it and a mapping argument passed to it. For the lines layer, we can actually just get rid of that mapping argument altogether. For the points layer, we actually still have a mapping that isn't common across things, so it still needs a mapping argument if we still wanted that coloring to be different across the different levels of num. So let's run that. Run, add, print, and it still works. So now we're getting a little bit less typing.
Just to reiterate and be clear, so canvas is like an arbitrary word, but really what you're doing is you have a ggplot function and it's accepting different layers inside it, which you're now telling it.
Well, the ggplot function returns an object. That object I then can add other objects to. This being there is critical, that it's a ggplot object, so that R then knows what add even means. It means like something graphical that's adding together. And if these other objects are the result of calling layer, then it knows that you're adding on all these geometric things.
Another aside. This still looks messy with all the up and down. Is it possible to block these things? So, for example, you would block engine displacement from 3 to 3.5 liters.
Oh,
is this something you do with ggplot, or is this something
no,
you
we'd
would
probably
do
do that
dplyr?
using dplyr first. Like if you wanted to group together a bunch of the engine displacements, etc. You do that with dplyr, and yeah. So putting common like values to the various arguments right in the first call to ggplot is one way to reduce typing. Another way to reduce typing is, actually, I'm curious. So other redundancies, stat equals identity and position equals identity is common to both of these geom layers. So that's, I'm going to try taking them out. I'm not sure that's going to work. Okay. Create no, okay, so no, that's not going to work. And that's because, yeah, I've been showing you layer as like this common thing that you can just change what geom you want, and it has the same structure from like the creation of one layer to another. That's actually typically not how people do things. More common is, instead of saying geom equals point, I'm going to take that off. And instead of saying layer, you actually call geom point. So ditto, instead of saying geom equals line, you could actually say geom line. So I'll run this as is, so with the stat equals identity, position equals identity in both for now, just to check it, convince you that geom point and geom line are functions that can be called. And it creates the same thing as usual. So a little bit less typing. But the key is that geom point and geom layer are just sort of simpler ways of saying the same thing, which is you're creating a layer that has a geom of either point or line, depending on which one you do. Yeah.
Sorry, just back to my previous question. So with the canvas, I guess what I was confused by is that you're creating an object canvas based on ggplot, and you're setting data as NPG there. But is that, and then that's carrying through the layer objects that you make?
Yeah.
All those are like distinct objects.
Yeah. So and it
ggplot.
exactly. So it's when they get added together that this object looks to, like if it's missing its data argument and its mappings argument, it looks to this one for what to grab for those arguments. So yeah, it's when they're actually combined that they actually talk to one another.
So what would, just out of curiosity, what would it look like if you didn't add one of those four things other than canvas?
Like, so there we go. So what happens if we just say canvas?
Points layer or something, like, or just canvas, yeah.
Yeah, so it just creates a canvas. Since we've given it the data and the mapping, it actually has produced a plot. It's taken the range of each of those axes to produce something. It just has nothing in it.
Oh,
Yeah.
okay. Cool.
If we hadn't actually produced that, if I just call this ggplot, it's nothing. It's just an empty. Now it actually is, like you can see there's a background there, so it has tried to draw something, but it's just an empty canvas, really.
And if you didn't have the ggplot function and just tried to do points layer, the points layer section?
So yeah, let's say point, just print that out. Okay, so it gives you some information as a printout. So points layer as an object, being the result of geom point, is smart enough to know that when you try to print it, it's going to give you some information about like how it was created, but it's not going to try to actually draw on anything because it doesn't
interact with.
Exactly.
Okay, cool.
All right, so the code is getting a little less typing. Let's take off the stat identity stuff. So geom line now just becomes empty. We still have that mapping, that special mapping for geom points, so we're leaving that. I'm going to put stat identity, position identity right there. So now that's definitely less typing. I'll also say that there's no need to put stat equals identity and position equals identity because geom point by default adds in stat equals identity, position equals identity, ditto with geom line. So in addition to being a shorthand for layer geom equals point, geom point also adds in defaults for the stat and the position entries to layer. So it has a default of stat equals identity and layer, position equals identity.
If you were to just add position equals, what was the one that creates the
Jitter?
Yeah, jitter.
Yep.
You would know to like
Jitter it a little bit. So yeah, if I wanted non-default values for those, I'd say position equals jitter. And this should be interesting because it's going to, let me start from up here. It's going to jitter the points so they'll no longer be connecting the lines precisely. But the lines are at the proper position. Yeah. So that's definitely a lot less typing. I didn't show you that at the outset because, again, I wanted to show you that whenever you're creating sort of a geometric object layer, it's a common thing that you're just specifying something that has a geometric object, there's some mappings, there's some possibility for a different stat being applied or a different position being applied, but there's a commonality across those kinds of layers. And that's really what the grammar of graphics is about. It's that there's this common way, no matter what geometric object you're plotting, there's an underlying commonality about how to translate the data to something visual. So this is still really laborious and annoying to have to create this object, create a canvas, and then this other object, name it, this other object, name it, this other object, name it, and then add them all together and combine them. So much more common is to just do this adding as they're created. So we're not using pipes here. Pipes actually, ggplot2 predates pipes. If pipes had existed before ggplot2, well, the author says that he wouldn't have needed to change. There actually was a package called ggplot, but it didn't have all like the features of this. Anyway, the ggplot2 would be very different if we had pipes available. There's so much code now based on ggplot2 that he's unwilling to start using pipes within ggplot2, and everybody's stuck with just using pluses to kind of express a chain of things happening. So what do I mean by that? So we can, I'm going to take off all these equals. So we're not going to create something called points layer or canvas or lines layer or labs layer. And we're not going to do any of this part. What I'm going to do is, so here's my first call to ggplot. I'm just going to put an add addition symbol there. And after this one, I'll put an addition symbol. And after this one, addition, and nothing left to do after that. So this is much more common to see when you see people working with ggplot, is that they'll just do it all in one big sort of chain of additions. And just to show you that that actually works and produces a plot, there we go.
Previously they had to print combined, but how can you have to print this chain?
Because it by default prints the result when you have, well, anything in R, if you don't assign it to something, it tries to print it.
Okay.
So if I created something at the beginning, say my plot equals this, then I would need to put print my plot.
What happens
Oh, and that would do it too. Yeah, if I just put my plot there. Yeah. So yeah, this is much more common, is to have it. Sometimes I like to tab in everything after the first call to ggplot so that I can see myself that, okay, I'm carrying on this creation of the plot. Sometimes I'll actually double tab this in. So sometimes I'm inconsistent still on how I do it, but I think the default in the RStudio is once it sees the add, it adds a tab, I think. So notice one thing we can actually do. Here we said MPG, pipe it to group by, pipe it to summarize, save as a thing. We actually didn't need to do that. We could just, ggplot as a function is compatible with receiving a data set to then plot. So if we weren't going to do anything with this MPG2 data set anytime after, we just wanted to get this single visualization, there's no need for assigning it to an object. We can actually pipe it to a call to ggplot2, in which case we don't need to say data equals anything. It's ggplot is going to receive the data set from the pipe, and I'll tap that in.
So you can pipe things to ggplot2, but you can't pipe within.
Yeah, yeah. When you're sort of creating a plot, once you've started creating the plot, you have to start using the add sign to express that something is, it's an ongoing creation. So it's a lot more to play with in terms of these plots. I'll show you though a couple things. So I've shown you how to print it out here, but maybe you want to save it so that you're going to put it in a report or something. I'll keep the code like this so that we're doing it all as in a pipe. And I'll actually save it out to an object. My plot. Okay, so if I run this, it will create the object my plot. And if I want to show that on screen, I can just ask it to save to file, ggsave, the thing, so ggplot2, ggsave. So ggsave, let's look for help. Save a ggplot with sensible defaults. Okay, so it's got an argument called file name. It's pretty self-explanatory. Put the file name, so I'm going to call it temp. The extension you put on it actually changes the behavior of what ggplot2 does. If I say temp.png, it's going to save a PNG file. A PNG file is what's called a bitmapped file. It actually computes, like, it's expressed in terms of a set of pixels. The alternative is something like PDF or SVG, but PDF is the more common. PDF doesn't express the data as pixels. It actually expresses the underlying data values and the actual vectors that are required to, say, for a line. It expresses a vector that says that, okay, draw a line from here to there. The consequence of that is that, well, actually let's just do it. I'm going to create a PNG first. With both of these, you have to tell it the width and height. So width equals, let's do 10, and height equals, let's do 6. These are in inches, I think. Yeah, unit chooses the first thing that's in this unit thing. So it's going to be a 10 by 6 plot. this DPI determines like how many pixels are in the bitmap file format. So 300 is fairly decent. Oh, and we have to give it the plot argument. Now the plot argument has a default value of last plot. So you don't actually need to give it a value there. If you don't give it a value, it's going to grab whatever was last plotted up in your screen. Still a good idea to always use it. So plot equals my plot. All right. So if I run save, that's going to save it to just wherever your working directory is. You could, if you had like a folder in your current working directory called, say, plots, you could save it directly into the plots folder. I don't. I think I just put it in my home directory here. Okay, so there's this file. If I open it up, if I click on it, RStudio is smart enough to know it can't open up a PNG, so it's going to open up my operating system's default file viewer. So there we go. So this is a PNG. If I zoom in, whoops, no, zoom, it starts to get fuzzy. Okay, so that's pixels. That's an individual pixel. Going back to RStudio, if I change this to PDF and save again, should show up there. Again, I'll click on it. My operating system will open up its own thing. And if I zoom, it is infinitely zoomable. Well, almost. So let's see, where's that? So the distinction, yes, enhance. So I highly suggest you only unless you encounter a scenario where the vector graphic version doesn't actually work with whatever software you're using. Most software is now smart enough to take a PDF and insert it as a figure, for example, in Word or Google Docs or whatever. It's smart enough to be able to insert a vector graphic, in which case it maintains the vector nature in that it's infinitely zoomable so that when it goes to print, it's nice. The bitmaps are just terrible for when you start printing because printing usually has much higher resolution than your screen can show. So it might look on your screen nice, but when you print it out, you can see that it's like choppy. So anyway, I always suggest using the vector graphic. I think it's smaller too. Oh, no. Yes, much smaller. So 2.6 kilobytes versus 250 kilobytes. There's also a GUI way of doing this save bit. So this export button, save as image, save as PDF. So image is the bitmap, PDF is the vector graphic. If you copy to clipboard, I'm pretty sure that's going to grab the bitmap. So probably worth the extra step of exporting, saving as PDF, and then importing rather than copying and pasting. But with either one of these, it's going to give you a little dialog that asks you what size, orientation, and where to save it. So, but I don't know. I don't find that. I don't find it so much more cumbersome to write the code to do it, especially where if you are then going to use this plot in a report, and you have lots of plots, say, in that report, and all those plots are made, it would be annoying to have to point and click to create each, like, say somebody gives you 10 more subjects, it would be annoying to have to go back through and point and click to create the plots for each of those, to save the plots. If you have it in your code as doing the saving, you just rerun the whole script, and it saves all the new plots, and you're good to go. Yeah. So that's all I want to cover today. Tomorrow we'll get into a little bit, or tomorrow, Friday, we'll get into more tweaking of the ggplot stuff so that you can add lots of cool stuff. So make it look very pretty. Cool. And I will turn off recording.